Hi guys, I'm going to be working through an example now of an experimental probability simulation using Excel. When you just have two different outcomes or you have two rounds, I'm going to be going through Kyle's example of drawing two different cards. Now I would set up your spreadsheet just like this, very similar to the previous example that we went through. Now for Kyle's example, in round one, you had to draw a card and you would go through if the card was not a king, a queen, or a jack. So in the outcomes column here, our first possible outcome is a king, a queen, or a jack. And the second possible outcome would be not a king, queen, or jack. And the way we write that is king, queen, jack, and then an apostrophe next to it means that we're looking for the opposite of king, queen, jack, or the inverse, which is not getting a king, queen, jack. Now, for your own game, you can adapt this based on what your two outcomes are going to be. Maybe it's a spinner with three options and there's a 1/3 chance of each of them happening. And so your outcome could be either a win or a loss. And the probability of a win would be 2/3. The probability of a loss would be 1/3. It depends on your game. But for Kyle's example, the probability of getting a king, a queen, or a jack was 12 out of 52. So you can just write equals 12 out of 52, and it gives you a probability there. The probability of not getting a king, queen, or a jack would be the leftover. So if 12 out of 52 cards were king, queen, jack, then the leftover would be 40 out of 52. So the probability of it not being a king, queen, or a jack is 76.9%, pretty close to 77%. So what that means is that the probability of winning round one is 77%, which is what Kyle would have worked out, what you needed to work out in your theoretical probability in your tree diagram. Now, the same thing as last example, we write our cumulative frequency. So it starts off as 0. In this next box here, we add together, or we sum those first two boxes. We get 0.23, and then we just drag that down, and we should end up with a total of 1, or 100%. Okay, that was our first round. So 23% chance of losing, 77% chance of winning. We now move down to round two, and for Kyle's example, you have to draw another card, and you win if the card is red. So the two possible outcomes there are either a black card or a red card. Now, pretty straightforward for black and red. There's only two options, so the probability is just going to be half for each of them, or 0.5 for both. And we do the same thing. We write down 0 for our cumulative frequency at the top, and then we add together or sum those first two columns. We end up with 0.5, and when you drag that down, you get 1 in total, so 100%. If you have 1 at the bottom of both of these columns here, it means that you're on the right track. So far we have our probabilities of both possible outcomes. The outcome of winning has a 77% probability in round one and a 50% probability in round two. And in order to work out the probability of winning your whole game, it's 0.769 times 0.5, and Kyle's worked it out to be 0.385, or 38.5%, and that would be his target probability overall. So once you have this table here set up, and remember, you modify this for your own game. I'm doing Kyle's example here, but if you have your own game with your own different outcomes and your own probabilities, you'll set it up the exact same way that we've set it up here. So what is your round one outcomes and probabilities? What are your round two outcomes and probabilities? And you may even have a round three, and you do this exact same process again for round three. And if you do have 3 rounds, then everything I'm doing here is the same, and you just add in a third column here for round 3. So let's start simulating now. So I'm going to imagine that 20 people are playing my game, and I'm going to randomly generate their outcomes for round 1, so the king, queen, jack outcomes. So we use this same formula that we looked at last tutorial. I'm going to start typing in here from scratch. So equals index. Remember, that tells us where we're getting our information from. What are our 2 outcomes? So you simply highlight your 2 outcomes for round 1. Now, just remember, though, you have to put in your dollar signs or this whole process doesn't work. So dollar signs next to the numbers, comma. Now we're going to match the randomly generated numbers to what we have here. So match, bracket, rand, bracket, bracket, comma. And then we highlight our cumulative frequencies that match up with our outcomes. And we remember to put in our dollar signs here, or it won't quite work. Okay, now we have our first result, our first player, round one. They drew a card that was not a king, a queen, or a jack, which means that they're essentially through to the next round. So we drag this box down here, and now we have results for our first 20 players for round one. You can see some of them got a king, queen, or a jack. Some of them didn't. That's good. That means that it's working. If you have any NAs popping up or like no numbers, just check that you've put your dollar signs in next to all of your numbers. Okay, now you'll notice when I click out of it, it changes. These results are going to keep changing. So I did say that we need to lock those down, but let's lock them down once we've got our round two results finished. And round two is done exactly the same way. We write equals index bracket. We highlight our outcomes for round two. So black or red, remembering as always to put in our dollar signs, comma, match, random, comma, then we highlight our cumulative frequencies for those. Remembering again to put in your dollar signs. That's probably the one biggest mistake that you may make, is that you forget to put your dollar signs in. Okay, now we have a black first outcome for round two. We drag that all the way down, and now we have our results here. And you notice they change quite frequently. Now that we have these, we can lock them in. So we copy all of them, and then we paste 1, 2, 3. You should see a little clipboard comes up with paste 1, 2, 3. Now those values are locked in. They're not going to change once we do our analysis. In the top here, this little box here, I've got win if score is. So this is just where you write down, how do you win? What combination of outcomes will give you a win? And for Kyle's example here, we're looking for not a king, a queen, or a jack. And then for round two, you need to draw a red card. So we've said here what we're looking for a win, not a king, queen, or a jack, and then a red. So what we need to do now is count up out of these 20 results here, how many of them were not king, queen, or jack, and then red for the second outcome. The way we do that is we write equals count ifs. Now we're going to highlight our first round of results, just like that. For this one, you don't need to do dollar signs because we're not changing anything, we're not dragging anything down. So just highlight those numbers there, comma, and then in inverted commas, we're going to tell it what we're looking for. So we're looking for, in brackets, king, queen, jack, close bracket, with an apostrophe to show that it's not the king, queen, jack, and then you close the inverted commas there. That's the first thing we're looking for. And then the second thing we're looking for, comma, is our second lot of results. We're looking for our round two results. So you highlight your round two, comma, you tell it what we're looking for, and we are specifically looking for, in inverted commas, anytime the word red appears. So anytime a red card is drawn. And then we close our brackets, and it will tell us, out of those 20 trials, so you want to fill in 20 in that number of trials, 8 of them won. 8 of them were not a king, queen, or a jack, and were red. Now we need to work out our probability of winning. So we predicted with our theoretical probability that it should be a 0.385 or a 38.5% chance of winning. So what we need to do is look at our results and see whether our first experiment gave us a similar probability. So what we do is we write equals, remembering our formula, number of favorable outcomes divided by total number of outcomes. We're going to click on 8 for our favorable, and we're dividing it by the number of trials, which was 20. That was the total number of outcomes. So our probability was 0.4. To convert that into a percentage, very simple, equals 0.4 times, with an asterisk, 100. And so we had a percentage of 40%. So when we did our experiment the first time, our experimental probability was 40%. So we can write that here, theoretical is 38.5, our experimental was 40%. And that's pretty close, but if you're not happy with that, you can run this experiment again. You can keep running it until you get something that you're happy with, that's closer to that 38.5. What we could even do is, instead of locking this in when we did it the first time, we can just keep it running constantly. So I'm going to really quickly just copy these formulas in again, just so they're ready to go. I'm going to copy this one in as well, and we're just going to run it again. Maybe we'll even increase the number of trials to 30 instead of 20. Okay, so we've got our king, queen, jack here. We've got our red and black here. Okay, now we've got a 40% chance. If I just click anywhere in this box here and I press enter, it will run the experiment again. You'll notice all of these numbers change and our probability gets recalculated. So once again, I'm going to click here. I'm just going to press enter. Now we've got 10 out of 20 with 50%. I do it again, we've got 55%. Do it one more time, 50% again. Then I'm down to 40%. So you can run this a few different times until you get a percentage that you're happy with. So here's 35 there. Now you may not get exactly 38.5 because we've only got 20 trials. The next thing you can do is increase the number of trials from 20. So you highlight maybe a few of those numbers there, you drag it down to 30. You'll also need to drag both of these down as well because these need to be replicated too, all the way down to 30. And then you'll notice that everything else changes. You have up the top here your summary table still. What you need to do when we increase this to 30 trials is go up the top here and change that 20 to 30. Now, once you've done that, you'll now have some different calculations up here. So let's run that simulation. Remember, just click on the top here and just click enter, and it's going to run that experiment multiple times. Here's one here that's 36.7. That's getting pretty close again to our 38.5. 23, 20, 23 again, 30, 27. So you can run it multiple times until you find something that's pretty close to your theoretical probability. And then you can just take a screenshot of this and paste it into your solve section. And remember, you do have that plus or minus 2% buffer as well. So as long as your experimental probability is getting close to your theoretical probability, and that is very close to your target probability, then you should be all good.